Hi guys, and welcome again to SmartPrep. Today we are continuing with our NBT exam preparation. We're going to be doing part 2 of our text and comprehension, which is a section E of your NBT AQL. Now, if you're looking for NBT maths, you are in the right place, but on the wrong video. Please subscribe to our channel. And then go through and look. We have our NBT Maths playlist, which I will put in the description. AQL playlist as well, the rest of the videos. So this is section E. So if you're new to the channel, we've got section A, B, C, and D that are already done. This is going to be the longer section, which is our text and comprehension. And this is part B. So let's get to it. All right. So here we go. Okay, so I've already read through this in part A, so I'm not going to read through this whole thing. So if you want to go back and check out part A first, it would make more sense. If you are now itching to get going with the rest, I am going to quickly summarize for those of you who are new. What we're talking about here is a comprehension where there was talk of these new ultra capacitors from a country called Estonia, which is outside of the usual America, Europe, and Japan, where most of this technology is developed. So this is a big win for Estonia, and so this just talks about the massive breakthrough that the Estonians have made, and let's get to it. So I will also, again, post a link to this past test, as well as all of the other past tests. If you are a bit worried about these not finishing in time, which is the major issue, I think if you had enough time, you could certainly do all of these questions pretty well, not easily, but it's the time pressure. So if you have done a lot of these past papers, it just makes it a lot easier, because then you're likely to get the same one in your MBTs, and it's just going to go through really quickly, and you won't run out of time. And those trickier questions you will get right because you got the answers. So, as I say, memos and past papers are in the description and the comments. All right, the following diagram summarizes some of the information in paragraph 2. Complete the missing information by answering the questions below. Okay, so we've got, all right, so we've got 47 is going to be split into, so this is going to be your energy storage, right? And then it could be either batteries or, I'm assuming, capacitors. All right, so 47 is energy storage. And then it could either be batteries. So we could actually just write this in, right? This is going to be energy storage. The types of energy storage, right? And they talked about batteries and capacitors. Now we know the capacitors are stored in plates, whereas batteries store the electricity in electrodes. If you guys have got any background in the physical science, you remember that your electrode, your anode and your cathode, positive and negative, and then the energy goes from one side to the other and just keeps getting recycled in a battery. And so another thing about the capacitors is it's just going to be static electricity, whereas this is chemical storage, right? So this was static. So I'm just putting in my answers, and then hopefully they fit in with something that is going to be here. So 47 energy storage is indeed there. We're hoping that 48 will have the option of capacitors. It does, so that'll be C. Then we are hoping that 49, I think was 49 was electrodes. We're hoping electrodes is there. It is indeed there. And then 50 static electricity. Okay. Now, I think I went through that a bit fast. So skip through to 51 if you got that. I'm just going to go through this again because I did go through it slowly. So What this diagram does is it sort of starts with your main heading, and then what it does is it branches off into two different options. Okay, so this could be like pets, right? And then it could be like cats and dogs, right? And then or maybe birds, right? And then here it could be the amount of legs, it could be 4 legs, and birds could be then 2 legs, right? So, something like that. So yeah, it just separates it into different categories. All right. Okay, so let's get rid of that. I don't do that anymore. It wasn't pets. Okay. All right. Now, let's see. I can afford to make this. Yeah. Behind me, you can see the members. Thanks very much. I don't know. I thanked everyone in part A, especially our new members. Yeah, we really appreciate the members, and we've got loads of exciting stuff for all our members coming up. And then the next video, I'm going to share the WhatsApp group link for the members only, and that will have an option for you to then ask any questions you like that you're struggling with in maths, accounting, all of those subjects that you'll be doing, not just limited to matrics, it'll be any grade. And we do also do university courses right up to third year university. You'll check on SmartPrep. Senzo and I have done courses there as well as our instructors. So lots of stuff at smartprep.coza. If you leave matric and go to UCT or WITS or TUX, wherever you go, we've got courses there that we do for those subjects. So yeah, lots of stuff we're trying to get done. And yeah, as I say, the members help us to build the site. Okay, so let's look at this type of question. The comparison fish, water, bird, air can be read as fish is to water as bird is to air, right? So fish swims in water and a bird flies in the air. Okay. So batteries operate chemically when capacitors work statically. Do you remember that? So the capacitors work statically. That's how they don't operate like squirrels. Squirrels was just a metaphor for storing away energy. Material operations does not make sense. Physically does not make sense either, because even a chemical change is somewhat physical. So it is D. Let me just get our pen back. So that's going to be D. Okay, so you see how these work. Let me just check. This is not C. Hang on. Capacitors. Okay, I'm just going to go up again and just look at capacitors quickly. So batteries store energy chemically. Capacitors stored physically. Okay, so it's actually physical. I thought, yeah, chemically and physically. Okay, I'm glad I checked that. Okay, although scientifically they're both technically physical, it's more correct. So to say physically. Okay, so let's go back to that. Sure, I'm glad I checked that. Okay, so they operate physically, not statically. So it's a static electricity, but it operates physically. Okay. I'm not sure if this was set by a high-level scientist, because one could argue the. Okay, complete the following comparison in the same way. Battery is to X. Okay, so a battery stores. Okay, so battery electrodes to plates and battery to capacitor, right? So 52 would be D, because we talked about battery and capacitor. And electrodes to plates, right? So battery links to electrodes and capacitor links to plates. Okay. So just asking it a little bit other way. I would have asked it as battery is to electrodes as capacitor is to plates, but yeah, doesn't matter. Still the correct answer. Okay, the word this at the beginning of the fourth sentence of paragraph 2 refers to the following phrase in the previous sentence. Okay, equivalent of electrodes clings to the surfaces, the static electricity in capacitors. Okay, so we need to actually look at the fourth sentence of paragraph 2 to see which one it refers to. Paragraph 2, yeah. Fourth sentence of paragraph 2. I think it would be better for you guys to get hold of this. So, as I say, for the members, what I'm going to do is I'm going to actually join the WhatsApp group, and then I'll just post this to the link. And then for non-members, you can get it off our SmartPrep website. Okay, so it's 199 Rand, but you literally get every single past paper and memo for AQL. All right. Okay, so paragraph, unlike batteries which store, was it the fourth sentence? It's 1, 2, 3, 4. This static can be tapped. Okay, so it was a static. Okay. So that was static electricity. So that was option C. Okay, complete the following comparison by choosing from the options below what X might stand for. So speed of discharge of batteries, X, speed of discharge of capacitors. So we know that if we read it carefully, that the capacitor discharge was 1,000 times greater than your battery discharge. Okay, so if capacitors is rapid, batteries would not be as fast, right? So it would be gradual. So it would be A. Okay. The delivery of short bursts of power mentioned in paragraph 2 is exemplified in paragraphs. Okay, short bursts of power. So, okay, so we've got to, that was towards the end. As I say, if you probably want to read this through twice. First time slowly, and then second time a bit quicker, so you don't run out of time. As I said, if you've done all the past papers, you may get the same, much more likely to get the same paper, comprehension come up. It'll be quicker. Okay, so we know 4 talks about 1,000 cycles, so that's speed, and 25% savings. Things we talked about 4 times more power. Okay, so let's go back. Okay, so short bursts of power was 4 and 5. Okay. The comparison. Okay, so now we have X is more storage capacity in capacitors and batteries. So which one had so we know that capacitors were quick but didn't have as much storage. So whereas batteries had more storage but weren't as quick, right? So they had less. So 56 would be A, less storage. So just in summary, capacitors, quick, short bursts, batteries, slow, but can hold a lot more power. So that's why batteries kind of get used more in solar. Right now we have a solar system outside. That's the solar from the roof, and now I am running off batteries, which is perfectly quick enough. Okay, and it lasts the whole night. All right, the word they in the last sentence of the second paragraph refers to. Okay, that was capacitors. All right, so now we're getting to, we've done this one a lot. We now know that second paragraph was capacitors, so I'm not going to go all the way up. But what you can do is won't have to, like myself, just keep scrolling, so it'll be quicker. All right, the word vim in the last sentence of paragraph 2, the almost slang, derives from the characteristic sound of quick energy, a very famous brand of scouring here. Well, I mean, it is called vim, but that's definitely not it, right? That's not true. No. So it comes from the word this. Okay, so that is one of those which you probably wouldn't have gotten. So unless you had watched this video, this would be the one where I would say probably you would have had to guess, but now you won't have to. So vis means force. Okay, so vis is Latin for force. Okay, so tricky one there. That's going to be the one that separates people from getting, the real smart English AQL whizzes. May not have gotten that one. All right, there is a synonym elsewhere in the text for the word accommodate in the last sentence of the paragraph. This is a synonym for. Okay, so a synonym for, that's going to be store, right? You can accommodate more people, you can store, or that can accommodate more storage, it can store more storage. Okay, let's do, should we do formal? Okay, the word this in the phrase this gap in the first sentence of the third paragraph refers to, so now we're looking at the third paragraph, the lack of storage capacity of ordinary capacitors, the speed with which the electricity can be used, the inability to release energy, other than rapidly, the inability thus far to handle energy chemically in them. Okay, so now we do have to go and let's just look at number 60. So I seem to remember that may have been talking about regular capacitors not having much storage. Let's see. Okay. Supercapacitors and their upscale cousins, ultracapacitors, tend to bridge this gap. So that was this gap. So this gap, they were talking about the gap between the fact that your capacitors don't have enough storage. Okay, so this is the gap. Okay, so then we can go down. There we go. The lack of storage capacity in ordinary batteries. Okay, because we know it's very fast, the capacitors, and we know they can do it rapidly. And it doesn't matter that they can't handle energy chemically. They don't need to. That's not their purpose. Okay. It is clear from paragraph 3 that the difference between capacitors on one ultracapacitor and the other is that the latter have hand and supercapacitors have. It is clear that from paragraph 3 that the difference between capacitors on the one ultracapacitor on the other is the latter have hand and one. Okay, so that doesn't make sense. That the latter have. So on the other hand, is that the latter and the supercapacitors and. Okay. Let's just work this out. Okay, so let's just try. Okay, so we've got capacitors and ultracapacitors. What's the difference? Well, we know that the more, and it's nothing to do with speed. The ultracapacitors have larger plate surfaces as well as electrolytes. Yeah. Okay, so this seems to not make sense, but they are talking about the difference between capacitors and the one ultracapacitor, on the other hand, is that the latter have and supercapacitors and. So very weirdly written, but we do know that if we just read through the capacitors here, they have an electrolyte as well. So if we know anything about this third paragraph, which is what we're now talking about, they talk about the increased surface area and an additional electrolyte. So that is what the ultracapacitors have. Okay, supercapacitors and ultracapacitors. So although the sentence is a little bit weird, the question is a little bit weirdly worded. It really doesn't flow nicely. We do know the answer at least. I think the hand goes there on the one hand, ultracapacitors on the other, is that the latter have. Yeah. But I mean, it's the more rapid and discharge is not true. Added something that was invented in the lab doesn't, it's just, that's random. And scale up in the stakes and the energy storage was, so none of the others make sense when you compare ultracapacitors and capacitors. Okay, what batteries have in common with supercapacitors and ultracapacitors, but not with ordinary capacitors, is that, well, they have electrodes, right? Because the ultracapacitors had electrodes added onto them. Electrolytes, sorry, electrolytes. Okay, well, that was the electrolyte is a way to store, because an electrolyte, for those of you who don't know, is just a solution which can store charge, right? So it's got electrons or ions, not necessarily electrons, but electrons are ions technically. So yeah, it's a solution which can conduct electricity, basically. All right. The reason for my answer to the previous question can be found in the phrase them. They soon run out of, attempt to bridge this gap, increasing the surface area of the sort found in batteries. Okay, that was found in batteries. Okay, the electrolytes are found in batteries. with reference to paragraph 3, which is the odd one out in the following, which is the odd one out? Okay, so paragraph 3. So a bridge is right. These are all capacitors, and a bridge is not. Okay. So is the odd one out. Okay, let's just double check. It's not a trick question. 64. Okay, paragraph 3. Supercapacitors, ultracapacitors, bridge. Ah, okay, they didn't talk about capacitors. So it's bridge. Ah, okay, so it was a trick question then. Wow. Okay. So there was no just checking, probably reading too deep, but it's capacitors. That's the only one that wasn't mentioned. Okay. In reference to paragraph 3, there was no capacitor mentioned in paragraph 3. Okay, that was a trick question. Good job, we checked. Okay, the phrase new device in the second sentence of paragraph 3 refers to the ultracapacitor mentioned in paragraph 1, capacitors mentioned in paragraph 2, supercapacitors mentioned in paragraph 3, and kinetic energy recovery systems in paragraph 4. Okay, so that would be it's either A or B because we know capacitors weren't mentioned. Sorry, A or C. A or C. Now we just have to look at paragraph 1 and see if ultracapacitors were mentioned. They were. So ultracapacitors were mentioned in paragraph 1. So then we know that it was ultracapacitors. Okay, so we have, let's just check how many questions we have. So in the next video, okay, so we've got 8, so we've got 15 more questions. We've done about 35 in this section. All right, so let's just stop sharing here. Okay, so I'm going to just duck down there and thank all the members behind me. We really appreciate you subscribing. If you have joined as a member, subsequent to this video being released, I will mention you guys on the next video that I record. But yeah, thank you very much for our subscribers, our members, everyone who comments, everyone who likes, for keeping us going and encouraging us to continue with our channel. Senzo and I have a big plan to do as much as we can. And so all the money that we get, we are investing into audiovisual equipment and just producing more content. So please do all the good things for us, and we'll keep doing all the good things for you. And as I said, members, stay tuned for the next part C video where we'll do the last few questions on this section, and I will post a link to the members only WhatsApp group where you guys can interact with us. Thanks again for subscribing and being part of the SmartPrep community. Really, things are going well, and we hope to continue to help you guys out. So all the best if you are writing your MBTs soon. And yeah, we will see you on the next video.